Kia ora Year 12. This video is for Chinmay and it's from the November 2018 paper. It's a trig equation question and it follows quite a common format with a couple of little differences. So it's one of these ones where we have to take a trig expression and turn it into this compound angle formula. The only difference here is that instead of just being given an expression, we're given a whole equation, blah blah equals √3, and we have to turn it into this trig expression, but it equals √2. So obviously we're going to have to just see how we're ending up going from this √3 here to this √2 here. And then we have to solve that equation using whatever we got in part 1. So the first thing that I notice in here is that I've got cosec and cot, and I really don't like that. So let's just take a look at that equation and see what the obvious first steps are to manipulate it. And remember that I'm trying to end up with a √2 over here. Now it turns out it falls out pretty easily. So I've got √2 cosec x, so that's √2 over sine x plus 1, cot x, cos x over sine x is equal to √3. Let's multiply through both sides by sine x and we get √2 plus cos x is equal to √3 sine x. And now we can very easily subtract cos x from both sides to get √2 is equal to √3 sine x minus cos x. And you can think of this as being minus 1 cos x. The next thing we're going to do is work with this and write this compound angle formula out. So we've got r sine of x minus alpha, and that equals r sine x cos alpha minus r cos x sine alpha. Now matching up the coefficients gives me this. R times cos alpha has to be this coefficient here, √3, and r times sine alpha has to be 1, right? Not -1, but just 1. So let's work with that, and then we're going to draw a little triangle. So we've got r cos alpha is equal to √3, giving me cos alpha is √3 on r, and here we've got r sine alpha is equal to 1, so sine alpha is 1 over r. Now we know that alpha is in the first quadrant, so that means that we can draw a cute little triangle that looks like that, and that's 1 and √3, and alpha is going to be this angle here, and that gives me that r by Pythagoras is equal to √3 squared, so 3 plus 1 squared, which is 1, so r is equal to 2. Now we can take that value and we're going to work out what a alpha is, and in this case we're going to get a nice exact value. So sine of alpha is equal to 1/2, and we can see that that means that alpha is equal to this angle here, which we should know straight away anyway, is 30 degrees. Okay, so I'm working in degrees because I was given alpha in degrees. So the two key things that we've got to find here are r and alpha. Let's go back to the equation part. So where have we got to? Well, that was all a big detour, because what we're now going to do is to say, well, if √2 is equal to this, then we can rewrite that green thing as 2 sine x minus 30 degrees. So we have this √2, therefore √2 is equal to 2r times sine of x minus 30 degrees. So that's the first part of the question done. Okay, now what are we asked to do next? Right, so now we need to solve this equation here, but we've just shown that this equation here is this thing here. So we're going to go ahead and solve that. So this is very easy, 4 marks. This falls out to have some nice exact solutions. And we've got √2 over 2 is equal to sine of x minus 30 degrees. And we know that x has to be between, I think, 0 and 180 degrees. But we better go back and check that at the end. So we should spot straight away that this is 1 over √2. So it's coming out of this triangle, which means that x minus 30 degrees is going to be 45 degrees. So you could do this with general solutions, but this example is so straightforward that I probably wouldn't bother. So my first solution is that this thing here has got to be 45 degrees, and let's check if that's going to be in this range here. Well, that gives me x is equal to 75 degrees. Now, from that graph, we can see that our first solution is here and our second one is here. So this point here is at 180 take away 45, which is 135 degrees. So the second solution is going to be x is equal to 135 plus 30, which is 165 degrees. So two solutions there. This is the first one, and this is the second one. So there you go. Hope that made sense. There are very many questions in the past papers that follow this format, but this one was just a little bit different. As long as you remember your compound angle formulae, though, they should always be pretty easy to figure out. One thing to watch out for in here is that, and it just talked about this in the examiner report, that there were a few students who ended up trying to work here, oh, I don't know what I did there, with -1, working with a -1 instead of a +1. Whenever you do these, you need to be making sure that you've got a positive number here. Okay, if you've got any questions on that, just ask me in class or send me an email.